Hello, Internet.
Hello.
Just a recap on what we're doing today, where we're at, etc. So Tim and I are going to continue working on our Effect Native MCP server again, because we had fun working on that, and I think it's also something that folks want. I know I had streamed independently last week a little bit, some work on the MCP server, and got to a point where at least we could run the server through RPC. But Tim and I have been talking about whether or not we can leverage more of like the stuff that he's already built with RPC within our MCP server implementation. So we're going to take a look at that. Probably also let Tim roast a little bit of my code from the stream that I did without him. And I think we might start the stream by taking a look at an old PR of Tim's that we opened. I think while we were at Effect Days, you worked on that.
Yeah, I was starting to look into MCP at Effect Days, and because MCP uses JSON RPC, the first step was adding that to Effect RPC. But then encountered the whole notification thing.
Yeah, so we might take a look at the PR that Tim had opened and see whether or not we can flesh that out the rest of the way, because at the moment we're using the ND-JSON serialization layer for our server, and then we have a custom like JSON RPC layer on top of that. But it doesn't feel nice. So we're going to see if we can flesh out the rest of that PR that he was working on.
Cool. Here is the PR. So in RPC serialization, we already have a bunch of passes already for plain JSON, ND, new line, delimited JSON, which returns like a batch of requests by like seeking out the new lines and then splitting up the message. And the other one we have is message pack, which is like a binary, quite an efficient binary protocol. But for that we use a dependency that does all the efficient splitting and stuff for us. So this PR is looking to add an additional JSON RPC serialization. And it kind of like maps in between RPC's expected shape and the JSON RPC shape. So we have these functions here for encoding and decoding. So
I'm going to open up your PR on GitHub because I know Sebastian, like I said, had some good comments.
Yeah, we probably also want to support batching. So that could be a message or an array of messages. And then here we can just go array this array decoded. Decoded .NET decode JSON RPC message. Otherwise, a single one. So we're batching. And then there's kind of like two modes for JSON RPC. You can either use a protocol that's already supports framing, which is like a WebSocket, or something. Or you have like new line delimited JSON RPC, which is more protocols, for transports that don't support framing, like TCP or standard in or something like that. So for that, we can leverage the ND-JSON protocol, and in here get like the frames.
Yeah, I want to open the spec JSON RPC
decode bytes. So here we have an array of unknown. So that will be JSON decoded frames. And then some of those frames, I guess, could be batches. Maybe if we just do a flat map here. We just go this for pull out a frame. And then messages. And then for each frame, if that frame is an array, then we do that. Else messages.push decode, and then we return the messages. And maybe we'll just do like an optimization there. And then here we could just go pass encoded.
Is framing transport specific or protocol specific?
It's dependent. It's dependent on the transport. So like WebSockets are framed for you. Or like anything that supports framing, like event-based systems and stuff. Like TCP will just give you buffers, and then you have to split them yourself.
Okay. One thing I'm reading in the spec for JSON RPC here about request response related to batching is that the server, if a client sends client sends an array filled with request objects, the server should respond with an array containing the corresponding response objects.
Oh, yeah.
They can be returned in any order because you can process them concurrently. But I don't know if these protocols support batching in the response.
So what do we do here? Response. Yeah, an RPC server. We've got kind of like a workaround for that, for the HTTP JSON protocol, which is
By the
kind of
way, I wanted to tell you that after having worked with RPC, the library lower level for a while the other day, I have to say that the implementation is quite elegant. So kudos. I was telling my stream that you did a great job with this rewrite. So
thank you. It's still quite fresh, and there's like a couple of edge cases I found already, but seems to be working quite well for cluster.
it feels very nice to use, I've got to say. So
Great. Yeah, so in here we do like this weird workaround for as JSON, where we return a batch as an array. Yeah, not sure about response batches. How we're going to do that. Because the RPC kind of like works with callbacks. And the server itself doesn't really care if the request was sent in a batch or not. It just processes than one at a time. So at some point, something has to care and has to like collect the responses as they come back. And I guess that would have to be here. Which feels funny, but because here we've got the extension of an array. If array is array decoded. Maybe we have like some batch tracking. We would have to have the map of something.
JSON RPC has the ID for tracking request response, so we could index on the ID.
Yeah, the ID is optional, isn't it?
Yeah, but the ID is only optional, I believe, for cases where a response is not. Let me double check the protocol. In the request object, an identifier established by the client that must, the ID is an identifier established by the client that must contain a string, number, or null value if included. If it's not included, it is assumed to be a notification. The value should normally not be null, and numbers should not contain fractional parts.
So it's a number or a string.
And looking at the comment about null, the use of null as a value for the ID member in a response object is discouraged because this specification uses a value of null for responses with an unknown ID. Also, because JSON RPC 1.0 uses an ID value of null for notifications, this could cause confusion in handling. Yeah, so I think for our implementation, we should assume number string, not null, because we're using, even though null is a valid value, it's discouraged. So I almost feel like we shouldn't build it into our spec. Unless you want to.
We can try and decode it properly. So I guess we can just do falsy check here, decoded.id. Otherwise, we're going to have to filter those out somewhere. We're just now.
Well, for the response object, hang on. On the response side, the ID member is required. It must be the same as the value of the ID member in the request. If there was an error in detecting the ID in the request object, for example, if there's a parse error or invalid request, it must be null.
So for notifications, it should typically be null.
But per the spec, yes, but I don't believe the MCP server spec.
Yeah, the MCP does its own thing. It does its own thing in a lot of ways.
It surely does. It's a very strange spec. But I believe for our version, if the ID is not present, we should set it to null.
Yeah.
I think.
So some guy in the pub was like drunk thinking about MCP. How about we use JSON RPC?
Why not?
How about we send notifications as requests?
How about we let the server send requests?
Yeah. Yeah, it's a very weird use of requests. Technically, the requests for a notification would be a request, and then the subsequent notifications would be responses to that. I'm not so sure of JSON RPC, so if that's like a valid use of their spec. Anyway, we need to track batches.
Yeah, so if the ID is not present in the request or if it's null, we should be setting it to null in the response, I think.
Yep. So the response comes in and it's part of a batch. So the response schema, so this ID is the request ID, right?
Yeah.
So response ID is belonging to a batch. Then we need to collect it and wait until we have the entire batch. And we need to preserve order.
Interesting.
Okay.
The notifications are actually built into the spec to some degree. A notification is a request ID, a request without an ID. So there is actually like a notification in the JSON RPC spec itself.
Right.
I think that
what does the server do? Does it just send responses back?
a notification is a request object without an ID member. A request object that is a notification signals the client's lack of interest in the corresponding response object, and as such, no response object needs to be returned to the client. The server must not reply to a notification, including those that are within a batch request. Notifications are not confirmable by definition since they do not have a response object to be returned, and as such, the client would not be aware of any errors. So they're fire and forget. So notification is literally a request without an ID. And I'm just looking at like some of the examples here.
Okay. We'll do this for batches. So we'll decode the messages, which will give us back the RPC message. So then we'll just do a for let decoded message equals decoded. We need to go decode. Message dot tags. Technically, we only should have requests here. Message tag equals requests. Here we have an ID, which is a string. And then here we create the batch, which will be a map of RPC message from server encoded. Yeah. Request ID to response.
I remember there was one specific nuance of the MCP.
Dot set message ID. And we'll just start off as undefined. And then once we're finished here, we add the batches to the batches.
Okay.
We need to go.
The only difference between the JSON RPC official spec and the MCP version of JSON RPC is that if an ID is sent, it can't be null. So that's the only difference. They like remove the whole concept of a null ID from their spec.
Okay. Patches. String. From server encoded. So this will be responses. And maybe if we track the size as well. So we responses.
Oh. Yeah, I think that's really the only other special stuff. There are a bunch of examples they provide, which we could use for tests when we get there.
Cool. Right. So kind of want to reuse this for this guy too. So if we go down here and go function decode JSON RPC, I guess raw. And what's the type of decoded? They're good. And we need the batch state. Cool. And now in here we just go return. And then we just need to do the response side. What's it?
The raw decoding will return what? First decode JSON RPC raw returns
an array of things, messages.
From server encoded and from client encoded.
So this raw thing will just do the batch tracking for us. So if the client sends an array of requests, it will go through each one. And if it has an ID, add it to the batches. And then batches is like a map of request ID to the corresponding batch. And then in the responses, we'll check when responses size matches that guy. And then send it back.
Cool. I like it.
I like it.
I like it.
I'm going to say edit here. Oops. I guess we'll go decode JSON message, JSON RPC raw, frame, and then we need to track the batches.
And the difference between the JSON RPC one and the ND JSON RPC one is framing.
Yes. So in JSON, we have to split the messages, whereas in this one, they're already split for us by the transport.
Got it. Cool.
So here we can just go messages dot push and spread that in, I guess. They'll probably complain about some unsafe stuff, but disabled.
When is this unsafe?
When this is too large, it will be you reach the limit of function arguments after a while.
Right.
And now we need to add the bit that encode. If it hasn't found the batch yet, then it wouldn't be a no-op. Which is fine for ND JSON RPC, but for this guy, it kind of has to return something.
Encode has to return something.
At the moment, yeah.
Mm. Hey, Trash Puppy. We are working on an effect native MCP server, but we decided. Hang on one second. Say it and get that phone call. We decided to take a step back and try to leverage more of what Tim's already built with the RPC. So we're working on. So in Effect RPC, the transport you use and the serialization layer that you use are both pluggable. You can use like WebSockets for transport and DJSON for serialization or whatever. Like they're all pluggable. So we're seeing if we can create a serialization layer for JSON RPC, which is the protocol that the MCP spec uses.
Sucker protocol. Yeah. And code returns undefined. There's a bunch of stuff we need to update. But it's not many places, so maybe it's one. Okay. So
Yeah, JSON RPC is a strange beast. Tim and I were just talking about that. The spec itself is like sort of weird, but the way that the MCP server, like the way that MCP itself works, is even stranger. So, but yeah, we're seeing if we can build this directly into RPC, it would be better because there's already so much that Tim has built with RPC that's really, really nice to use. It just requires a little bit of massaging to work well with the MCP spec. So we're seeing what we can do here. Where have you encountered RPC, JSON RPC in the wild?
let's check some code. No, maybe we should just do the branch for this JSON here. Return mailbox dot response. Otherwise, encode it. If encode is undefined, encoded.
Yeah, that's been Tim and my experience as well. The spec is definitely leaves something to be desired, but it's what we're stuck with. Certainly, I would love to know the decision making. I'm sure there was like I'm sure there was a rationale for why this spec was chosen for MCP, but I would love to know like the background. Like, what were it's always interesting to me, like whenever I question a decision like this, it's always interesting to me to learn like why the decision was made in the first place. So
I think the only other alternative would have been like photo or something like gRPC. So that would have been a pretty good choice.
I mean, gRPC would have been fine, I think.
Yeah.
But again, like, I don't like to bash too hard on other people's choices unless I like understand the like the logic. So at some point, if anybody ever finds like a blog post or something explaining why JSON RPC, I would love to read it. Just because to me it seems like a strange choice, but I wasn't there when the choice was being made. So some people probably think there's a lot of choices that we made in effect that are very strange. So, but they weren't there when the choices were being made. So.
Yeah.
Sorry, I've been ignoring you, Tim. What is the current problem we're solving?
We are doing the response side of the batching stuff. So if the batch exists.
No, don't come in my chat using that dirty P word, trash puppy. Python is a swear word. At my old job, I had a joke with my colleagues that they were not allowed to say that the word Python is a dirty P word in my presence. There was a project I worked on at some point with a mentor of mine when I was at Tumblr, where we were building a self-hosted Jupyter hub for our data org, and at some point the exposed like APIs and things like that were so limiting that at some point we found ourselves writing Python within YAML to generate YAML on the fly. So it was like you were writing Python in a YAML file to then generate more YAML to like update the pod that we were launching. It was disgusting.
Maybe we just check if it's not exit. It's not tag. Doesn't. It doesn't equal sure.
So Tim, just to make sure I understand again,
I think we're just interested in the exit case, actually.
The streaming case may come into play if we the streaming case might come into play when we're using the streamable HTTP transport, but I'm not sure yet. Because if I understand,
that actually doesn't really work with streams.
True. I guess we're gonna have to. I haven't even looked at the streamable HTTP like spec that they have.
Here, I'll just go request ID. Response. Okay, so if we get a response that's in the batch, then we remove it from the batch and then add the response to the batch. And if the batch size equals the response size, then we send it.
Cool.
And so here we can just go return. Otherwise, we return undefined. If it's not part of a batch, then we just encode.
Nice.
Okay. And then we go back here and use that thing. Just
I think we should only ever have one batch at a time, but I guess if we're getting batches in and not responding to them fast enough, that won't be the case, so never mind.
and then down here, we do the same thing. Encoded and pass it on encoded.
I don't know why we always get spam in our chat when we stream. It's always at least one, but we max out at 5 viewers. So I'm not sure why we get spammers in our chat, but
I think there is a setting to only allow logged in people or something.
I gotta find that setting. Let me see.
Or maybe there isn't. Alright, so now we have JSON RPC serialization that supports batches. We just need to make sure. I did make ID optional. I just made an empty string if the client sends something with an ID. What about encode? So if we send a notification from the server, yeah, that's fine. We do send a bunch of extra fields, but assuming most people will just ignore those.
I hope so, or we could just delete them. Oh no, but the client might need them.
Yeah, that would break. and things if you were using it for real with effect RPC.
Yeah, I have those settings set up. I think, Josh, probably I have it so that email verification is on for chatters, and then I have it set so that phone verification is only required if chatters have an account older than 1 week. So, I don't know. I'm really committed to spamming my channel with 4 viewers.
Encoded. This is HTTP. There should always be a response there.
Mm-hmm.
Cursor.decode messages. And watch it in the encode side. Yeah. Okay.
Do you already have a test suite set up for the RPC serialization or for the serialization for RPC? Because we could add a few simple ones.
We just have a bunch of end-to-end tests in here.
Because we could set up a simple
RPC server.test. ND JSON message pack. No, I haven't added JSON RPC.
We could have an RPC serialization suite, and I could just give you some of the examples or send you a link to them if you want to do that. If you don't, we could just test it against.
Just is it MCP?
I think I called my branch
Oh, there you go.
feet/AI-MCP.
Feet as in feet.
Yeah, feet.
Get rebase. JSON. RPC. So we go to MCP 7. Kicks. What is it for?
For context for the audience, this is the actual MCP server implementation that I was working on, and
Not sure why merge doesn't exist there.
do we have to like do a pm install or something, or
Probably.
might have to?
There we go.
Yes.
So if we go back to the server, fill the handlers. Great. This is the server stuff. Maybe if we just test doing like a make RPC constructor here. So here we'll need the client. What RPCs do?
It's the client RPCs that I pass into the no serialization constructor. So I think it would be the client RPCs that you'd want. And these are basically things that originate from the client, whether they're requests or notification.
Ping. That's weird. Yeah. Concurrency is fine. Management. Cool. So this needs a protocol. Headless middle. But we'll need like a proxy protocol that filters out the notifications. Server protocol, what do we got? Big. Or we just grab the protocol. RPC server protocol.
Yeah, I'm kind of doing something very similar in the current constructor, except I call it transport, but the same idea applies. It's like,
yeah. So send, we don't really need to overwrite, or do we? From server. No, that's not. But run, we do need to patch.
I guess,
because if this from client thing doesn't have an ID or whatever, or is an empty string, then we don't want to forward it, but we want to send it somewhere else to like notifications. We want to route it to wherever notifications go.
yeah, this is the, yeah.
Mm-hmm. But if the request is one of these guys, then just do the normal RPC thing. Yeah, let's give it a go.
Give it a go.
PC server protocol run between protocol.run client ID request. The request is particularly we need to typecast this because it could be a request. Oh, sorry, it could be oh no. We just need to check the tag, or if the ID is empty, if request.tag equals request and request ID equals. In here we would do notification handlers. Otherwise forward to the normal server. Down here we can go put provide service. So what are you currently doing in those handlers? Just type message. Nice.
The only handlers I've implemented are initialize and ping.
Yeah.
So the rest of them I'm just dying.
Okay, so what do they actually do behavior-wise? So if they send one of these...
Let's look at the spec. Hang on. I'll pull up the spec while we look at this. Okay. Notifications. Which notification are we looking at specifically? Canceled?
Canceled.
Life cycle.
I guess we'll get the payload. We'll get it right here. So we're canceling a request.
Cancellation. Okay. The model context protocol supports optional cancellation of in-progress requests through notification messages. So I guess when a party wants to cancel an in-progress request, it sends a notification canceled notification containing the ID of the request to cancel and an optional reason that can be logged or displayed. The behavior requirements. Cancellation notifications must only reference requests that were previously issued in the same direction and are believed to still be in progress. The initialized request must not be canceled. Receivers of cancellation notifications should stop processing the canceled request, free any associated resources, and not send a response for the canceled request.
Okay, so we just need to hook into RPC's interruption for that one.
Receivers may ignore cancellation notifications if the referenced request is unknown, processing has already completed, the request cannot be canceled. The sender of the cancellation notification should ignore any response that arrives afterward.
Okay.
And then due to network latency, just reading some more stuff in the spec. Due to network latency, cancellation notifications may arrive after request processing has completed and potentially after a response has already been sent. Both parties must handle these race conditions gracefully. Both parties should log cancellation readings for debugging. Application UIs should indicate when a cancellation is requested. Yeah.
Request ID. Payload request ID. String. We map notifications cancelled into interrupts. Initialize. I guess that just means the client is ready.
Yeah, so let's take a look. Life cycle. So initialize request. After successful initialization, the client must send an initialized notification to indicate it's ready to begin normal operations. The client should not send requests other than pings before the server has responded to the initialized request. Okay.
So how do we respond to it?
We don't. I don't know what we're supposed to do in the initialized case, but we don't respond.
Just ignore it for now. I'm guessing for all these notifications, we'll just be void. No.
Yeah, for progress, it's trickier.
Progress.
The model context protocol supports optional progress tracking for long-running operations through notification messages. Either side can send progress notifications to provide updates about operation status. When a party wants to receive progress updates for requests, it includes a progress token in the request metadata. Every single one of those requests has an optional meta field that can have potentially a progress token in it.
Right.
Progress tokens must be a string or integer value. Progress tokens can be chosen by the sender using any means, but must be unique across all active requests. The receiver may then send progress notifications containing the original progress token, the current progress value so far, an optional total value, and optional message value. The progress value must increase with each notification, even if the total is unknown. The progress and the total values may be floating points. Okay. Yeah.
Okay.
I guess that would be something that we can look at how the official spec does this actually too. In the exposed API, MCP, TypeScript, SDK.
List changed. Notification better.
This is first server. This first. Any examples? Server. Source.
Protocol 7.
Yeah, there's like a progress callback that I guess you can set with
But
protocol
for now,
requests.
we just swap scopes. There you go. Decode, where's decode? I guess I'll just try and run that and see what happens. Scratchpad MCP server. We'll need the handlers. So the handlers are down here. Client RPC inputs. Layer dot build. Client RPC handlers. Provide handlers.
Just trying to see if I can find anywhere where there's
MCP
examples.
server, MCP server implementation. And we would need a protocol. So we make a RPC protocol for standard out, standard input, standard IO. RPC server.
So the standard IO constructor is gonna double. I think it's gonna double. I don't know what you're working on right now, but I know that my standard IO transport thingy already encodes as like the RPC message.
It does the serialization as well.
Yeah, so we'd have to like deconstruct that a little bit.
That's fun. Where's that? Make protocol scenario. I don't really want to hard code Node.js stuff in here though. Because RPC doesn't care about platform.
Yeah, I had this in the AI package, but also I'm not sure.
Stream. Standard stream. That doesn't really make sense. Standard would be a sim. Or alternatively, it could just take a channel. So A is root string borage. In the SIPs, you can write into it.
You can write into
So
a
I go
sync,
stream.run. AER. Yeah. Leftovers. Errors. Let's just try that. See what happens. And those would now be required. Maybe if we just copy paste the socket one for now. There's only one client, which makes it a bit easier.
Yeah, we can hard code the client 0 for the standard IO one.
On socket. Maybe in here we just no, that's fine. Get rid of undefined. So standard in it's stream sync. and pass protocol to back. Send client ID will always be 0. Here we just need to write to standard, and so we do need the mailbox. And we just go mailbox offer. If possible. Also dot well, technically this could be input illustrator. Support spec.
I don't think we have X over standard or at all.
I'm just thinking for standard RPC server that would span propagation. I don't know what that does. Client ID ignore. So we send stuff to the mailbox, or should go to standard in. Possible. Okay. So here we would go options dot set it in the file. Stream dot run these for. Sure. So we have the kind of messages we then need to send them to the protocol.
Is there a reason we're using the make helper over just creating a protocol directly? Is there a benefit?
It does do some stuff for you. I can't remember what. Protocol.make. It does like buffering for you if you write messages and you haven't called run yet.
Got it. Yeah, I guess that's useful if the
Where do I actually call the function here? Oh, no, it's the run. Theory passing. What's it do for run? It's my brain is working this morning.
you and me both, buddy. My head is pounding today.
I think actually we can move this in. Move this all in here. We still need to access that stuff. We don't do disconnects, send, end. I guess end would do.
At the point that we decoded
So we need
messages.
to do write requests in here. So that feeds the messages in. And now we need to do the email box link. So we just go options. So we go mailbox to stream mailbox. But the stream don't run into options. So just take it out. And that completes. I guess here we would go. What's it in?
Cool.
Okay, so that is make protocol standard IO. It's HTTP section, web handler. Yeah. And then we just do a layout version, I guess.
And Copilot's getting good at writing effect.
It has like context. It does pretty well.
You've added some context, you said?
Or it has the context of the module.
Oh, I see.
Cool. So it still needs serialization, the Biswick protocol. Then here, we just put layer on. We just scope this down below. So we need layer dot provide, and then here we'll do RPC pro RPC server dot layer protocol citizen. Here would be node stream from readable. Era to era, and then stream down. And then standard out would be node sync. Sync dot. It doesn't have an order.
I guess not.
I guess in here we can just accept any errors. Error parameter and requirements. We should update make this. So we accept some generics. leftovers. Yeah, sure. Inbound.
Didn't you add generics for the errors?
Yeah, probably could at some point.
I thought you just added them.
We'll just discard them anyway.
Oh, no, didn't type them.
I guess technically do the requirements, get edit. Can't see. Exclude scope from the oops. In this errors. I guess the only thing we can do is a retry. Mm. And if that fails, it will be in E out, in out. In or out.
You're currently missing it. Oh, no, never mind. Never mind.
Okay. No, I can just get rid of that. RPC serialization. Or standard IO, we would need in the JSON RPC. Layer in the JSON RPC. And now we just need the MCP stuff.
Yeah, there's an example from the bottom of the MCP server file. You can copy in if you want for those two things.
Okay.
Right there. The layer that I create. Ow. The You can basically
yeah, we're just gonna layer.
layered up to find, layered out succeed. The only thing is that this will provide the handlers and stuff, so you may just want to delete those too. Things.
That's fun. So what have we got now? Proceed transport. No, that kind of like wraps everything up.
Yeah, that's why. You might just want to grab the two provide merges and just copy those things in instead. For now, to test.
Yeah. We'd have to probably create some nice layer things later. Or covering the different transports.
I think right now you can just delete the first two layers that you're creating there. Yeah. Yeah. I think it just needs a, yeah. And then I think in the transport and the MCP transport file, I think there's a compiler error right now.
We're not actually using that anymore.
True. True.
But yeah, we can fix that.
I can pass you the command to run the inspector if you want.
Okay.
You just have to update the path to whatever file you're going to run. But this will run it with bun. And then there's the PNPM variant. You just have to, like I said, add the relative path at the end.
MCP.
You won't need it. You won't need it running because the inspector runs it as a sub process.
I guess we need to pipe something to our server.
If you, yeah, you could either do that or we could, so the bunx run thingy is the just pass up the path to your scratchpad and stop the scratchpad running on the other side. Yeah, and then kill the bun thingy that you ran on the other side, and just like I said, you have to give it the path to the file. So just give it the path to your scratchpad server, and then you should be able to open up localhost 6274.
Yeah. I guess I need to change my presentee.
Is it working?
I guess my entire screen is probably a bit too big.
Hey, The initialize message is going through.
Ping.
Ping is working.
How can you tell?
Bottom, you can see request response in history, and you can see the initialize request there when you connected with our demo server. And then if any notifications were coming through, so I have a mock prompts thingy registered there. If you go to prompts on the top bar, it has all the feature. Like the top is where the capabilities are. So if you click list prompts, we should get an error. In the middle of the screen, sorry. If you click, yeah, there we go.
Requested.
Interesting.
Okay.
Interesting.
Sorry. So we go to MCP server. It should be running.
You know what it probably is, Tim? It's probably just because we're dying. It's not sending a valid like MCP response back. So it's just displaying to us as like
actually.
Like if you just straight up you fail with an MCP error.
The make. Disable fatal defects is missing. I feel like I should remove that option was in default to true. But that can be for something else. Disable true.
Cool.
Great. An error occurred.
Yeah.
Is it right? Probably. Does it show like the raw? No, it doesn't show the raw protocol messages.
No, you would have to do. So if you log out to console.error, it shows up. It's really, the UI is not the greatest, but if you do a console.error, it'll show up on the left-hand side in the sidebar. The problem is the sidebar is not expandable, so the errors are usually like hard to read. But if you log the console.error, it'll show up there. So try disconnecting, just see if it works. And then reconnect. Cool. Nice. Well, I think this is good progress for today. I feel better about looking more heavily into the RPC ecosystem is one of the goals I had. So this is much better.
Yeah, I guess we just need to clean up this stuff. That's a lot of provides.
Yeah, I mean, we could have a layer that wraps everything up nicely.
In the Node platform, we could add like a Node RPC server that has a standard IO layer that just does that.
Yeah.
Yes, I feel like JSON RPC is good because then if you wanted to do it over WebSocket or something, you could technically do that and provide a WebSocket protocol.
I think next time we should take a look and see whether or not we can hack together a basic version of the streamable HTTP transport. I don't know if we have the primitives to do that yet, but I think we do. So Anyway,
Yes.
I think this is a good stopping point for today.
Mhm.
Thank you, everybody who joined and watched, or who may be watching later. Hope you guys enjoyed it. And yeah, we'll see you folks next time.
Yeah.